Hello, my name is Alex Rodriguez and I'm going to be showing you how to solve this very simple case of isolation. For this specific example, we're going to be isolating the variable TO. As you can see, our variable is inside a set of parentheses. So to start off, we need to remove any variable that is multiplicating the parentheses. In this case, we divide both sides by MC. This way, we cancel out the MC on the right side. Now that that's gone, there's nothing left outside of the parentheses, so we can simply remove them. Now, to isolate TO, we just have to cancel out TF on the right side. Because TF is performing an addition, to cancel it out, we just subtract it on both sides. This leaves us with Q over MC minus TF is equal to negative TO. We're almost done. We just need to make TO positive. In order to do so, we multiply both sides by minus 1. Q over MC is a positive term, so multiplying it by minus 1 makes it negative. TF is a negative term, so multiplying it by minus 1 makes it positive. Finally, TO becomes positive. This is the final answer. Also, remember that you can move the terms around as long as you keep their respective sign. This means that negative Q over MC plus TF is equal to TF minus Q over MC. I hope you enjoyed and realized how easy it is to isolate variables.
Hi there, it's Stefano and this is Draw My Life. Draw My Math. Today I'm going to explain a very simple problem of isolation in 4 easy steps. First of all, we are going to isolate the variable VO in the next equation. So the first step is to write down your equation or the problem. The second step is to change or to place all the elements which contain the variable that we want to isolate to one side of the equation and the other elements to the other side of the equation, like we did in here. Here we change the sign because we are changing this element to the other side of the equation. The third step consists of eliminating the exponents. Here you eliminate the exponent of the variable by applying a square root to the other side of the equation. Now we are almost done, but this is not well written in mathematics. So the next step is to apply the symmetric property and write it down this way.
Okay, so basically today we are going to explain some isolation, and I'm George. Let's explain some rules. Do you remember that when we have a number dividing and we're interested to pass it to the other side, we should pass it dividing? Well, we have to do that, and vice versa. When we have a multiplying number, we have to pass it dividing. And when we have a number adding, we have to pass it subtracting, and we have a subtracting number, we have to pass it adding. When we have a square root or the square of a number, we have to pass the square root as a square of a number and the square of a number as a square root. And this one is the equation that I'm interested to solve now. VO equals the square root of v squared x plus vy squared. Okay, the variable that I'm interested is the variable that I'm interested is in vy. But now we have a square root and the variable is squared. So what I'm going to do now is isolate it and eliminate those obstacles. Okay, so first remember that when we apply to one side, we have to apply to the other side. So if I apply the square to one side, we have to apply to the other side too. So it will be like vr squared equals the square of the square root of vx squared plus vy squared, and the answer will be vr squared equals vx squared plus vy squared, because the square was gone with a square. And I'm interested in isolating the v squared y, because remember it's easier to work with positive numbers, and I'm going to pass to the other side v squared x, subtracting. So what I'm doing is to pass it and to isolating the variable that I'm interested. And now we have another obstacle, the square that is in the v of the y. Okay, so now I'm gonna eliminate the square by applying the square root to both sides, because remember that when we apply something to one side, we have to apply it to the other side. So when I apply it, it will be the result. The square root gets gone with the square of the vy, and this is the answer. Vy equals v squared r minus v squared x, all of that in a squared, and after that's the result after I apply the symmetric rule. Thank you. Goodbye.